Hello everyone, Eisenberg here. You look sky. Okay, I'm not gonna get into any story. Well, why planes fly? This is the question. The answer lies on its wing, and its shape. Well, basically, its body, or let me show you here. Its body helps it to overcome drag. What is drag? Drag is basically contractive force which doesn't let you go in full speed. It doesn't let you to fly in high speed. Air comes onto it and slows you down. Therefore, its body are shaped in a very special shape which decreases the drag. But why plane stays on the air? The answer for this lies on its wings. If you look from outside or from side view, you can see that. Maybe you can't see from here, but you can see it has very special shape. And that shape is called airfoil. How it is able to make the plane but how this airfoil shape can make the big airplanes stay on the air? Well, let's analyze. Okay, here it is. This is airfoil shape. This is basically what it looks like from side view. I mean the planes. And this is our air producer or smoke producer in order to see what's happening on the borders of this wing. Let's try it out. Let's move that here. So you see, it's somewhat similar to droplets, water droplet or liquid droplets, it doesn't matter. Let's start this animation and see what it looks like. Here it is. Well, it may take some time, just be patient. As you can see, oh, there's not much difference. Okay, what basically happens here is that air comes here, or I would say the amount of air under the wing is more than on the wing. And as a matter of fact, if there is high air here and low air here, it will create pressure difference. When there is a pressure difference, air or any substance will go from high pressure to the low one, which ultimately will cause this wing to go upwards. This is basically why planes stay on the air. From different perspectives. Well, you may firstly ask that, what are you talking about? There's almost no difference. That's because but angle of attack is too low. What's angle of attack? It's basically the rotation around x-axis, you see? Now I'm increasing the angle of attack. What that means is that now the air is highly likely to hit under part of wing, and its upper part will almost have little to no contact with air, which ultimately causes again pressure difference, and air will flow from high pressure to the lower one. Now you see that, oh wait, okay, it passed through it. Imagine this didn't happen. What the fuck? Okay, it is visible that, not that much visible, but you see that air under the wing is much more when it's compared to the lower part. Much air. The amount of air is too much here compared to this part. It will create force that will push the wing upward. Okay, if you didn't understand this, let me show another way. So basically, air molecules comes straight. If there is no wing, it will go straight away, yes? Of course. But when there's an object in front of it, it will basically hit the object and it will change its direction. downwards. Conservation. Okay, so according to conservation of momentum, if second object hits and changes direction, other object should change its motion or direction in the opposite way, meaning that it will go upwards, which is the main reason why planes fly. Okay, we understood that. Planes fly because of pressure difference or according to conservation of momentum. But why planes have, how to say, droplet-like shape? Again, airfoil. And the reason for it is that it will decrease the drag. Let me show you what I mean by comparing two objects' airflow. First of all, that cube. Let me put it a little close. Here it is. Air hits the cube. Air hits the cube. It is obvious that the amount of air in right hand side is much more than left hand side. In left hand side there is almost no air, and due to the fact that atoms or molecules of air hits objects due to Newton's second law, F equals m multiplied ma, it will create a total force in the opposite direction of the object's velocity, F drag. So cube obviously is not an ideal shape to build a plane. What else can be used? Well, again, droplet shape. Let me show it real quick. Airfoil shape. It's clear that very distinct from the cube. In cube, the amount of air on the right hand side was too much, which ultimately created pressure difference. And what we said previously, that pressure difference causes an object to move from higher pressure to the lower one. But here you can see that the amount of air on both sides is okay. It's again, there is a difference, but not that much. Ultimately, it dramatically decreases the drag. Air flows in that direction. It follows the shape and do not necessarily create a vacuum on the back of the plane, and it reduces drag. Well, you may ask then, what it is used for? Well, that's because airplanes have center of mass approximately here. Imagine this place, imagine this part is not located here. There is no like rear wing. What will happen is that front end will be much more heavier, which will cause it to rotate around this point. But this wing will create torque on the opposite direction around this point, which will create balance between front and back, and will not cause any rotation on the plane. Why it's like that? It's going through it. Anyway, one extra and necessary thing I should mention is that the higher the velocity air molecules have, there will be much more lift on this wing, which will easily move the plane upwards, or in other words, it will go much more distance in a short period of time. So the more speed you have, the less time you will spend for going upwards. So speed is the key. Well, I hope I explained something about planes. See you in the next video.